Hi and welcome back. To get data from databases, we have to use SQL queries. And actually, SQL or SQL stands for Structured Query Language and is a very powerful and versatile and also complex tool. And one could create a separate 10 hours course just on SQL queries. So this is still a pandas course, but we have seen that we can load data from databases directly into pandas by passing SQL queries to the pandas.readSQL method. And in this and the next lectures, I will show you the very basics of SQL queries and how to perform simple SQL queries to pull data from our movies database into pandas and Python. And actually, SQL queries are really intuitive as they are somewhat like simple English sentences. So it's not like a programming language. And let's import pandas and SQLite 3, and we connect to our movies database. And now let's pass the very first and probably the most simple SQL query to read SQL. And actually with select all from movies, we can get all columns from the movies table. And actually the asterisk symbol stands for get all, and this is not anything SQL specific. So we know this also from other programming languages like Python, that we can unpack or get all elements with an asterisk. And then we have here two SQL keywords. We have select and from. And in SQL, they are actually uppercase. So with uppercase characters. And first of all, we have the first keyword select. And here we can select the columns that we want to get from a specific table. So in total we have 4 tables, and here we want to get all columns from the table movies. And again, we have to pass the SQL query here as a string to read SQL, and we also have to pass our connection. And here we get the movies table in a pandas data frame. And actually in SQL, it's pretty common to have the commands in separate lines. So in the first line, we have select all columns, and then in the second line, from the table movies. And we can extend a string over more than one line with a backslash. So that's why we have the backslash here. And this gives the same result. So later, when we have more complex SQL queries, then we will use this structure here. So we will have one command per line. So select all columns from movies. Of course, it's not necessary to select all columns from a table. So we can also select specific columns. And let's have an example here. So in this example, we select the columns ID, revenue, and release date from the table movies. And this works as well here. And actually it's important to notice that here on the left hand side we have a range index, because we didn't define an index here with the parameter index col. Next, we can also get some summary statistics on a specific column. And let's assume that we want to get the total revenue, so the sum over all revenues here. And therefore, we can do the following. So we select the sum in the column revenue from the table movies. And actually, here we get a data frame with only one element. It's the total revenue. So still, we have here a data frame because we are using pd.readSQL. But we can also have here the single number, and actually we can also execute the SQL queries with execute. So here we have our connection, and then we have the method execute. And also here we can pass our SQL query, so selecting the total revenue from movies. And if we use the execute method, then to get the results, we have to chain fetch all. So let's have a look here. And here we get a list, and in this list there's a tuple, and the first element is actually our total revenue. So we have to go here inside the list and the tuple to get the total revenue as a single number. So in this course, I will stick to the first option, getting all results with pd.readSQL. And therefore, next we can also get the the number of non-missing values in the title column. So we can count the number of non-missing values in the table movies. And it's no surprise that we get here 18. And now let's do the same also for the belongs to collection name column. And we know that not all movies belong to a collection, so we have some missing values here. And therefore we can also determine the number of non-missing values with count. And here we get only 15, so we have 15 movies belonging to a collection and 3 standalone movies. And next we can also get the number of movies or rows in our movies table. So we count all rows or all movies. And here we get 18. And last but not least, we can also get the average budget in the budget column. So the mean or the average budget for the 18 movies. And here we get 209 million. So these were some simple examples, and let's close our connection. And I'll see you in the next lecture. Bye. Alright, here are some more SQL queries, and the focus here in this lecture is on conditional filtering of database tables. That means that we only import those rows or those movies into Python and Pandas that meet certain conditions. And this is one of the main motivations for working with Pandas and databases in parallel. So in particular, if you have very large data sets, so we keep most of the data in the database and only load those data into Python and Pandas that we are interested in. And that's not only more memory efficient, but also improves the performance of Python and Pandas. And again, we import Pandas and SQLite 3, and we create a connection to our database. And then with the where keyword, we can actually filter the movies table only for those rows where we have the movie ID 597. So in total here we have 3 keywords. So we select all columns from the movies table, and only those movies or only those rows where the ID is 597. So this is pretty simple and straightforward, and here we get Titanic. And actually one important side note here. So typically the keywords in SQL queries like select from or where must be uppercase, so with uppercase characters. However, when passing SQL queries to Python Pandas, then Python Pandas is actually smart enough to handle also lowercase letters. So if we have here select with a lowercase s, then this also works. But we should definitely stick to the convention and have the keywords with uppercase letters. And now let's go on and let's select all movies and all columns where we have a revenue greater than 2,000. So we have the column revenue, and the condition is that the revenue must be greater than 2,000, which is actually here $2 billion. And in total we have here 4 movies. Next, we can also combine conditionals with an AND or an OR operator. So now let's have a look at the next example. And here we want to get all movies with a revenue of greater than 1.5 billion and a budget of less than 200 million. So these movies are actually pretty profitable, and let's have a look here. And here we have Jurassic World and The Fast and the Furious 7. And also here AND should be interpreted as a logical AND, so both conditions must be met. And if we had here an OR, then at least one condition must be met. Now let's go on and let's select from those movies where the revenue is greater than 1.25 billion, the minimum value in the budget column. And this is here 125 million. Next, we can also get unique values in a specific column with the keyword distinct. So with select distinct title, we get the unique movie titles in the column title from the movies table. And actually we have 18 movies and all have actually a unique title. So we get here 18 titles. But this will change if we select the unique values in the belongs to collection name column. So I guess there are some movies that belong to the same collection, and therefore we have duplicates in this column here. And in total we have 9 unique values here in this column, including none for missing value. Then we can also order our results or our rows by a specific column in ascending or descending order. And here we select all columns and all rows or all movies from the movies table. And we order the movies or the rows by the budget in descending order. So we have here 2 new keywords, order by and descending. And here we are starting with the most expensive movie, Avengers Endgame. So here we have sorted by the budget from high to low. Next, we can also get those movies or those rows where we have a missing value is null in the column belongs to collection. So in other words, those movies that are actually standalone movies. And here we get 3 movies, Titanic, The Lion King, and Beauty and the Beast. And of course we can also get the opposite. So we can get all rows or all movies where we do not have missing values in the belongs to collection column with the keywords is not null. And here we have all of the other movies that actually belong to a collection. And finally, we can also perform text or string queries with the like keyword. So we are searching all movies that have the following pattern in the title. So we are searching for Avengers, and then we have a percentage sign. And this is a wildcard for one or many characters. And let's have a look. And here we get Avengers Endgame, Infinity War, and Age of Ultron. So these are the 3 Avengers movies. Alright, we have reached the end of this video, and we close the connection, and I'll see you also in the next lecture. Bye. Alright, in this lecture we are going to work with 2 tables of our database, and we will perform join operations on the tables and load a joined or merged table into pandas. And actually, join operations is a pretty complex topic, not only in SQL but also in pandas, because there are a handful of different join types. So we have inner joins, left joins, outer joins, right joins, and more. However, based on our tables, we can keep it pretty simple here. And first of all, let's import pandas in SQLite 3, and we create the connection to our database. And now let's assume that we want to join the tables movies and votes. And actually these tables are linked by the movie ID, so let's have a look. And first of all, let's get the movies table, and then the votes table. And in both tables we have the movie ID. And again, this is a pretty simple case, because all movies or all movie IDs are in both tables. So in total we have 18 movies, and all of the movies we have in both data frames or tables. And this makes it pretty simple, as we do not have to differentiate between inner joins or left joins or whatsoever. And therefore, if we simply want to merge both data frames on the movie ID, we can do the following. And in total we have here 4 commands, and each and every command is in a separate line. And first of all, we select all columns from the movies table that we are going to join with the votes table. And actually the join should be on the ID column. So here we have to use the keyword join and the keyword on. And then we have to define the columns that we want to join on. And we have to do this here with the following code. So we have to say explicitly that you want to have the ID column in the movies table equals the ID column in the votes table. So if you are working with 2 or many tables, we have to define the table the column is coming from. So here movies.id and votes.id. And again, of course, we have to pass here our connection object. So let's have a look here. And this is the joint table or the joint data frame with all columns from the movies table. and all columns from the votes table. So we have ID again, vote count, and vote average. And actually we can see here that now we have the movie ID twice. So from the movies table and the votes table. And therefore we can also slightly change our SQL query and select only a few columns. And that's exactly what we are going to do here. So we select only the ID column in the movies table, then the title and the vote average. And the remaining part of the query is the same as above. But now we have only 3 columns, and also we defined that we want to have the ID as the index. So now we have the movie ID, the title, and the average rating or the average vote. And now we can also combine other operations like conditional filtering. So again, we merge movies and votes and get those 3 columns. But only those rows are those movies that meet the following condition. So we only want to have movies with a vote average of greater than 8. So we simply add here the where statement. And here we only get 3 movies, 2 times Avengers and Harry Potter. And finally we can also chain another operation. So we can actually change the order of the movies here. And for instance, we could sort the movies by the budget in ascending order. So from low to high budget. And now we are starting with Harry Potter with a budget of 125. So we actually also added here the budget column. All right, these were some simple join operations with SQL and pandas. And let's close our connection. And see you also in the next video. Bye. Hi and welcome to the final case study where we will use pandas and SQL for more advanced data analysis. And first of all, let's import pandas and SQLite 3 and we connect to our database. And now let's try to answer the following question. So what are the most successful production companies in terms of total revenue? And the plan is now to join the tables production companies or prod and movies and load a joint table into pandas, and then we will group and aggregate the data with pandas. And actually also SQL provides group by operations, but that's beyond the scope of this pandas course here. And therefore the plan is to load the merge data that we require from the database into pandas, and then we analyze and aggregate the data with pandas. And so far we haven't worked with the prod table. So here we have the production companies for each and every movie. And actually there can be more than just one production company for a movie. So for the first movie we only have Marvel Studios. Then for the second we have actually 4 companies. And now the plan is to get the movie title and also the revenue from the movies table here into the prod table. And actually this is a left join. So the left table is here our production table, and the right table is our movies table. And we want to join on the movie ID. So this is nothing new, and we want to get the movie ID, the company name, so the production company name, the movie revenue, and also the movie title. And actually we save the resulting data frame in df. So this is here the merge data frame, and so here we have for the Avengers only Marvel Studios and the revenue. Then for Avatar we have 4 companies and the corresponding revenue for the movie and so on. And actually also here we have a special case because we have all 18 movies and the IDs in both data frames. So we could also work here with an inner join. So this gives the same result, or just the join, which is by default an inner join. But actually if we have more complex data, and actually the more general solution would be to have here a left join. So now we have the production companies and the revenues for those movies where these companies were involved, and now we can actually group the data frame by the production companies and actually calculate the sum of the revenue, so the total revenue. And finally, we can sort the results from high to low. And let's have a look at the most successful production companies. And here we have Walt Disney, then Marvel, and so on. Now let's perform another left join on the table's production company and movies. And let's assume that we are interested in the production companies that were involved in the movie Titanic. So again, we perform a left join, and we are only interested in the company names. And we actually filter the results for those movies where the title is Titanic. And here we get a data frame with only one column, company name, and actually those production companies that were involved in Titanic. Finally, let's work with the two tables, movies and genres. And let's assume that we are interested in the most successful genres in terms of total revenue. And this is actually the very same task as above. So we perform a left join and get all revenues for all combinations of genre and movie ID. So for instance, we have here 3 genres for Avengers, Endgame, Adventure, Science Fiction, and Action, and we also have here the revenue. And the same we have here for all combinations of movie ID and genre. And also here now we can group DF2 by the genre name, and we can calculate and aggregate the revenue and get those genres with the highest revenue. And this is here adventure, then action, science fiction, and so on. And finally, we can also get the genres for a specific movie, like for instance, Frozen 2. So again, we perform a left join on the movie's ID and only get those genre names where the movie title is Frozen 2. And here we get a data frame with one column and 3 elements, adventure, animation, and family. All right, now let's close the connection here. And we have reached the end of this case study. So I hope you enjoyed it, and see you also in the next one. Bye.